So your agent and my agent and her agent and his agent will all combine to solve a new problem. You know what we should do? Pull the plug. Literally unplug the computer.
최근 AI 분야에서 점점 더 강력한 생성형 AI가 등장하고 있는데요. 챗 GPT, 스테이블 디퓨전, 깃허브 코파일럿 등 다양한 AI 모델들이 급속도로 성장하고 있습니다. 하지만 이러한 AI들이 발전함에 따라 우리의 미래에 어떠한 영향을 미칠지, 생활 속에 녹아들면서 그 역할이 얼마나 중요해질지에 대한 인식도 함께 성장해야 하는데요. 이번 영상에서는 해외 유튜버 노마 매거진이 에릭 슈미트 구글 전 CEO를 인터뷰한 영상을 번역하고 요약해왔습니다. 지금부터 에릭 슈미트 전 CEO의 인터뷰를 통해 AI의 미래를 엿보러 가시죠.
The key thing that's going on now is we're moving very quickly through the capability ladder steps. And I think there are roughly 3 things going on now that are going to profoundly change the world very quickly. And when I say very quickly, the cycle is roughly a new model every year to 18 months. The first is basically this question of context window. In fact, that context window can have 1 million words in it. And this year, people are inventing a context window that is infinitely long. And this is very important because it means that you can take the answer from the system and feed it in and ask it another question. Let's say I want a recipe to make a drug or something. They say, what's the first step? And it says, buy these materials. So then you say, okay, I bought these materials. Now what's my next step? And then it says, buy a mixing pan. And then the next step is, how long do I mix it for? You see, it's a recipe. That's called chain of thought reasoning. And it generalizes really well. We should be able, in 5 years, for example, to be able to produce 1,000-step recipes to solve really important problems in science, in medicine, in material science, climate change, that sort of thing. It's the first one. Second one is agents. And an agent can be understood as a large language model that knows something new or has learned something. So an example would be read all of chemistry, learn something about chemistry, have a bunch of hypotheses about chemistry, run some tests in a lab about chemistry, and then add that to your agent. These agents are going to be really powerful, and it's reasonable to expect that agents will be, not only will there be a lot of them, and I mean millions, but they'll be like the equivalent of GitHub for agents. There'll be lots and lots of agents running around and available to you. And the third one, text to action. And what that is, write me a piece of software to do something, right? You just say it. I mean, can you imagine having programmers that actually do what you say you want? And it does it 24 hours a day. And strangely, these systems are good at writing code such as language like Python. You put all that together, and you've got infinite context window, the ability for agents, and then the ability to do this programming. Now, this is very interesting. What then happens? There's a lot of questions here. And now we get into the questions of science fiction. I'm sure the 3 things I've named are happening because that work is happening now. But at some point, these systems will get powerful enough that you'll be able to take the agents and they'll start to work together. So your agent and my agent and her agent and his agent will all combine to solve a new problem. At some point, people believe that these agents will develop their own language. And that's the point when we don't understand what we're doing. You know what we should do? Pull the plug. Literally unplug the computer. So it's really a problem when agents start to communicate in ways and doing things that we as humans do not understand. That's the limit in my view.
And you think again, how far off in the future is that?
Well, there have been many, many predictions. Clearly, agents and these things will occur in the next few years. And it won't occur in there won't be one day where everybody says, oh my God. It's more a question of capabilities every month, every 6 months, and so forth. A reasonable expectation is we'll be in this new world within 5 years. And the reason is there's so much money. And there are also so many ways in which people are trying to accomplish this. You have the big guys, the 3 large so-called frontier models, but you have a very large number of players who are programming at one level lower, at much lower cost, who are iterating very quickly.
Right.
Plus, you have a great deal of research. I think there's every reason to think that some version of what I'm saying will occur within 5 years and maybe sooner.
Wow, now, so you say pull the plug. So 2 questions. So how do you pull the plug? But even before you pull the plug, if you know you're already in chain of thought reasoning and you're headed to what you fear, don't you need to regulate at some point that it doesn't get there? Or is that beyond the scope of regulation?
Well, a group of us have been working very closely with the governments in the West, and we've started talking to the Chinese, which of course is complicated and takes time, about these issues. And at the moment, the governments, with the exception of Europe, which is always kind of slightly confused, have been doing the right thing, which is they've set up trust and safety institutes. They're beginning to learn how to measure things and check things. And the right approach is for the governments to watch us and make sure we don't get confused on what the goal is. So as long as the companies are well-run Western companies with shareholders and lawsuits and all that, we'll be fine. There's a great deal of concern in these Western companies about liability, doing bad things. Nobody wants to hurt people. They don't wake up in the morning saying, let's hurt somebody. Now, of course, there's the proliferation problem, but in terms of the core research, the researchers are trying to be honest.
Okay, so that's the West. So by saying the West, you're implying that proliferation outside the West is where the danger is. The bad guys are out there somewhere.
Well, one of the things that we know, and it's always useful to remind techno-optimists in my world, there are evil people and they will use your tools to hurt people. My favorite example is the face recognition stuff was invented not to constrain the Uyghurs. They didn't say, we're going to invent face recognition in order to constrain the minority in China called the Uyghurs. But it's happening. All technology is dual use. All of these inventions can be misused. And it's important for the inventors to be honest with that. So in open source, which is, for those of you who don't follow it, open source is where the source code in models, the weights, that is the numbers that have been calculated, are released to the public. Those immediately go throughout the world. And who do they go to? They go to China, of course. They go to Russia. They go to Iran. They go to Belarus. They go to North Korea. When I was most recently in China, essentially all of the work I saw started with open source models from the West, which were then amplified. So it sure looks to me like these leading firms, the ones I'm talking about, the ones that are putting $10 billion eventually into this, will be tightly regulated. I worry that the rest will not. You can see, I'll give you another example. Look at this problem of misinformation. I think it's largely unsolvable. And the reason is the code to generate misinformation is essentially free. Any person, right, a good person, a bad person, has access to them. It doesn't cost anything, and they produce very, very good images. There are regulatory solutions to that, but the important point is that cat is out of the bag, or whatever metaphor you want. It's important that these more powerful systems, especially as they get closer to general intelligence, have some limits on proliferation. And that problem's not yet solved yet.
Follow up on your point about the funding. Fei-Fei Li at Stanford argues that's the biggest problem, is that there's so much money going into the private sector. And who's their competition to look at what the red lines are or whatever? It's the universities, which don't have a lot of money. So you really trust these companies to be transparent enough to be regulated by government that doesn't know what they're talking about, really?
The correct answer is always trust but verify. And the truth is you should trust and you should also verify. And at least in the West, the best way to verify is to use private companies that are set up as verifiers, because they can employ the right people and so forth. So in all of our industry conversations, it's pretty clear that the way it will really work is you'll end up with AI checking AI. It's too hard. Think about it. You build a new model, it's been trained on new data, you've worked really hard on it. How do you know what it knows? Now, you can ask it all the previous questions, but what if it's discovered something completely new and you don't think about it? And the systems can't regurgitate everything they know. You have to ask them chunk by chunk by chunk. So it makes perfect sense that an AI would be the only way to police that. People are working on that. With Fei-Fei's argument, she's completely correct. We have the rich private industry companies, and we have the poor universities who have incredible talent. It should be a major national priority in all of the Western countries to get research funding for the hardware. If you were a physicist 50 years ago, you had to move to where the cyclotrons were, because they were really hard and expensive. And by the way, they still are really hard and expensive. You need to be near a cyclotron to do your work as a physicist. We never had that in software. Our stuff was capital cheap, not capital expensive. The arrival of heavy-duty training in our industry is a huge economic change. And what's happening is that companies are figuring this out, and the really rich companies, I'm thinking of Microsoft and Google as an example, are planning to spend billions of dollars because they have the cash, they have big businesses, the money's coming in. That's good. Where does the innovation come from? They don't have that kind of hardware, and yet they need access to that.
Are they moving as exponentially as we are in the West with the billions going into generative AI? Does China have the commensurate billions coming in from government or companies?
It's not at the same level in China. My estimate, having now reviewed it at some length, is that they're about 2 years behind. 2 years is not very much, by the way, but they're definitely behind. There are at least 4 companies that are attempting to do large-scale model training, which is similar to what I've been talking about, and they're the obvious big tech companies in China. They're hobbled because they don't have access to the very best hardware, which is restricted from export by the Trump and now Biden administrations. Those restrictions are likely to get tougher, not easier. And so as the NVIDIA and their competitor chips go up in value, China will be struggling to stay relevant because their stuff won't move at the same.
You agree with not letting those chips China?
The chips are important because they enable this kind of learning. It's always possible to do it with slower chips, you just need more of them. And so it's effectively a cost tax for Chinese development. That's the way to think about it. And is it ultimately dispositive? Does it mean that China can't get there? No, but it makes it harder and means that it takes them longer to do so.
And we should do that as the West.
Well, the West has agreed to do it. I think it's fine. It's a fine strategy. I'm much more concerned about the proliferation of open source. And the reason is, and I'm sure the Chinese would have the same concern. So again, these are the kinds of things that we'll be talking to them about is, do you understand that these things can be misused against your government as well as ours?
Right.
So the scenario is open source folks basically do something called basically guardrails. And they fine tune and they use a technology called RLHF to eliminate some of the bad answers. There's plenty of evidence that it's relatively easy. If I gave you all of the weights, all of the stuff, so forth, it'd be relatively easy for you to back them out and see the raw power of the model. And that's a great concern. That problem's not been solved yet. Yeah, reverse engineering, and that's not been solved yet.
자, 이렇게 AI의 발전과 윤리에 대해 아직까지 적극적으로 발언을 하고 있는 에릭 슈미트 구글 전 CEO의 생각을 한번 들어봤는데요. 그는 AI 기술이 단순한 혁신을 넘어 우리의 삶을 어떻게 더 나은 방향으로 이끌 수 있는지에 대해 강조했습니다. 무한한 컨텍스트 창, 에이전트, 텍스트 투 액션 등 중요한 기술들이 미래를 어떻게 변화시킬지에 대한 그의 생각도 함께 나누었는데요. 저희도 이런 트렌드에 맞춰 AI를 받아들이고 함께 살아가는 세상을 만들어야겠죠. 저희 기묘한 자동화에서는 이러한 비전에 맞춰 AI 전문 프로젝트를 운영하고 있는데요. AI를 활용해 트렌디한 서비스를 만들고 싶으시거나 GPTS API를 활용해 서비스를 구축하고 싶으시거나 AI 기능이 탑재된 쇼핑몰을 구축하고 싶으시다면 더보기란의 링크를 통해 저희 홈페이지에 오셔서 문의해 주시기 바랍니다. 저와 함께 여러분들의 AI 사업을 구축해서 함께 성공해 보시죠. 이번 영상은 여기까지였습니다. 구독과 좋아요는 영상 제작에 큰 힘이 됩니다. 감사합니다. 지금까지 쿠키였습니다.